Welcome. Today we're going to do something a little different. We're going to run through a kind of technical interview, breaking down the absolute fundamentals of computer networking. So, have you ever stopped to think about how you're able to watch this right now? It all comes down to a shared set of rules. We're going to demystify the two blueprints for all of it, the OSI and TCP IP models. Let's get started.
All right, first question. Let's start at the very beginning. From the perspective of, say, a tech support engineer, someone who's in the trenches every day, what exactly is networking?
Well, from that point of view, networking is everything. It's the absolute lifeline. You can think of it as the central nervous system of any company, really. Its entire job is to make sure every single computer, device, and user can stay connected and do it securely and efficiently. It's all about troubleshooting, configuring hardware, and just keeping everything running smoothly so the business doesn't grind to a halt.
Okay, good. So let's build on that. That seamless connection you're talking about, it doesn't just happen, right? It's all built on specific frameworks that act like a universal language for all our devices. Let's dig into the two big ones.
So that leads to our next question. What is a network model? Why do we even need one? Why can't your phone just, send a photo directly to my laptop?
Right. A network model is basically the blueprint for that whole communication process. It's a way to take this incredibly complex task of sending data across the globe and break it down into smaller, much more manageable steps. And this is so important because it standardizes everything. It's the reason a phone made in one country can talk to a server in another without a problem. And the two big models we always talk about are the OSI model and the TCP/IP model.
Okay, let's dive into that first one you mentioned. Tell us about the classic, the OSI model.
So, the OSI model, that stands for Open Systems Interconnection. It's been around since 1984. The best way to think about it is like a very detailed 7-layer cake. Each layer has a very specific job to do, and it only talks to the layer directly above or below it. It's an amazing conceptual tool for engineers, especially for troubleshooting. If something breaks, you can figure out exactly which layer the problem is on.
Excellent explanation. So, if the OSI model is this perfect theoretical guide, what about the model that actually runs the internet today? What is the TCP/IP model?
Exactly. The TCP/IP model is the workhorse. If OSI is the detailed textbook, TCP/IP is the practical, field-tested guide we actually use. It's much more streamlined, with just 4 layers instead of 7. This isn't just theory. This is the foundation of the modern internet. It's literally what's making this communication possible right now.
Great distinction. To really get this, I think we need to peel back the layers. So let's take a closer look at that 7-layer OSI cake.
So can you walk us through them? What are these 7 layers, and what does each one actually do?
Absolutely. Let's go from the bottom up. Layer 1, the physical layer, is just what it sounds like, the actual hardware. The wires, the cables, the Wi-Fi signals, sending raw ones and zeros. Then layer 2, the data link layer. Make sure data gets between 2 devices on the same local network, error-free, using hardware-specific MAC addresses. Layer 3 is the network layer. This is the big one. It's like the global postal service for the internet, using IP addresses to route data packets across thousands of miles. Up from there is layer 4, the transport layer. Think of this as quality control. It makes sure all the packets of data arrive and that they're put back in the correct order. Layer 5, the session layer, manages the conversation, opening and closing the connection, like keeping a video call stable. Layer 6, the presentation layer, is the translator. It handles stuff like encryption and compression, making sure the data is in a format your apps can actually read. And finally, layer 7, the application layer, is the part you see and touch, your browser, your email client, the app you're using.
Whew, okay, that is a lot to remember. But there's a really handy trick for it, a classic mnemonic. To remember the layers from top to bottom, 7 down to 1, just think of the phrase, all people seem to need data processing. Application, presentation, session, it works perfectly.
Okay, that's a perfect breakdown of the theory. Now let's shift gears and do the same thing for the more practical TCP/IP model.
So, how does TCP/IP take all those jobs and condense them into just 4 layers? Please outline those for us.
Yeah, TCP/IP really simplifies things. It starts with the link layer at the bottom. This basically just mashes the OSI's physical and data link layers together. It handles all the hardware and getting data onto the local network. Next up, the internet layer is pretty much a one-to-one match with the OSI's network layer. It's all about IP addresses and routing. The transport layer is here too, doing the exact same job, making sure data arrives correctly with TCP or just gets there fast with UDP. And finally, the application layer combines the top 3 OSI layers, session, presentation, and application, into one big layer that handles everything the user interacts with.
So it's a much cleaner, simpler stack to picture. And of course, there's a mnemonic for this one too. For this one, just remember all teachers and luck. That gets you application, transport, internet, and link.
So there you have it. The OSI model is the detailed, theoretical blueprint. It's perfect for learning and for troubleshooting problems. But the TCP/IP model is the practical, streamlined engine that actually powers our entire digital world. The next time you're scrolling, streaming, or sending a message, just picture those invisible layers all working together perfectly to make it happen. And that really leaves us with one final thought to consider. As our world gets more and more connected, are these decades-old blueprints going to be enough for what comes next?